Good morning. This is Elementary Statistics, Math 1401, and today is June 21st. All right. Most of you took your exam. I believe all of you. The performance wasn't bad. You guys did fine. If you have any questions on exam, on your exam, of course, I can record it here and upload it. You have to email me. I'll be happy to included in the next day's recording, and this applies to all the homework problems. You have to clearly tell me what course you're talking about, and then you have to tell me the number. Ideally, give me a screenshot. I'll be happy to work on the problem for you. So let me go over a few things, guys. Exam 2 is going to be on June 3rd. I'm already working on the study guide for exam 2. It should be here. It's on July 3rd, not June 3rd. All exams are going to be cumulative. I have tried to list all the sections that I plan on having. I won't be surprised if you wrap up 5.5, 5.6, and do the next couple of sections. I don't know, but that's all tentative. I will cut off where our lecture stops, so don't panic. Don't email me about the syllabus of exam 2. It's here really for me, and I didn't delete stuff for exam 1. It's all here, okay? So just be aware of that. It should be in the pipeline. Exam 2 on July 3rd. Other than that, we're going to work on 5 point. Let me double check. We're going to work on 5.5. We're going to continue working on 5.5, and we're going to talk about permutation. I'm going to bring this slide here. So we left off, we did an example, and that's where we left off before exam 1. All right. So what is permutation? I can read the slide, but it's not going to help a lot. I'll give you an example. Okay. Don't worry about this formula yet. We're going to get to it. Well, let me get rid of this formula if you don't mind. So suppose, let me take a question. Suppose you want to arrange 5 books, of course, 5 different books in a row. How many ways can you do that? Suppose you want to arrange 5 books. Let's write 5 as follows in a row. How many ways can you do it? Well, you're going to tell me, well, that's easy. It's like counting principle. And it is. It is. You're going to tell me I have 5 books. So I have 5 slots. This is the first one. This is the second one. This is the third one. This is the fourth one. This is the fifth one. You're going to tell me, well, that's easy. I can choose a book for the first slot in 5 different ways. One of the books is not available. I can choose a second book for the second slot in 4 different ways. Third, in 3 different ways. The fourth one, only 2 books are available, 2 different ways. And the fifth one, there's only one choice, 1 different way. Now, and then I'm going to just multiply it. My answer is going to be this. And whatever that may be. Now, last class, we also said when you have 5 times 4 times 3 times 2 times 1, you can actually write it as 5 factorial done. You can leave it that way, right? Now, on the exam, you will be able to leave it that way. But let's find out. Today is our first day, so let's find out. 5 factorial, you can use Desmos, is 120. So you can arrange 5 books in a row in 120 different ways. This is nothing more than counting principle, what we did last class. But this is also permutation. Permutation is a special form or special aspect of counting principle. In permutation, order matters because you're arranging things. And in permutation, repetition is not allowed. The first book you choose for the first position, once you choose it, that book cannot appear any other time. You're arranging things. A couple of keywords that go with permutation is arrangement, order, where order is important. So this is permutation. Now let me do one more example. Okay. Suppose you have to arrange 5 books in a row of 3 slots. Uh, 3 slots. What does that mean? That simply means you have 5 books, but you only have 3 positions. All right. There's room. Let's say these are identical paperbacks. Okay. You have 5 identical books of identical thickness. The books are not identical. These books are all the same thickness. You have room for arranging 3 books only. Okay. So you're going to say that for the first slot, you have 5 choices. For the second slot, you have 4 choices. For the third slot, you have 3 choices. So the answer this time will be this. I think it's 60. I'm going to double check. I do make mistakes. 5 times 4 is 20. I don't have to check. This is correct. 5 times 4 is 20. 20 times 3 is 60. I'm pretty confident this is correct. So you can do it in 3 different ways. Now, this is also a form of permutation, and this is written as follows. We're going to write it like this. Okay. I'm going to show you another way your book writes it. Okay. It's a little hard for me to write here that way. Your book, I'm going to show it to you. It means the same thing. Your book writes it this way. 5 permutation 3. They mean the same thing. I tend to write it this way. All right. Now, 5 permutation 3 means, I'm going to delete this. Okay. 5 permutation 3 simply means like what we have above, 5 times 4 times 3. Now, we can't write 5 factorial. We cannot, right? Because I have 2 and 1 missing. But what if I do write 5 factorial? 5 factorial, and then divide it by 2 factorial. Now I'm good. Now I'm totally fine. Look, 5 factorial is, how do I know I'm fine? I'll show you in in, in the next text box. Next text box. 5 factorial is simply, as we have established, and 2 factorial is 2 times 1. And 2 times 1 and 2 times 1, they cancel. What are you left with? You're left with this. So you have to understand 5 permutation 3, or in our example, if you have 5 different items and you want to arrange them in 3 slots, you don't have 5 slots available. You only have 3 slots. How many ways can you complete your task in this way? How many ways? In 60 ways. And this turns out to be 60. Okay. You want to understand one more thing. Sometime your book will, MATLAB will expect you to write 60. MATLAB will expect you to write this, permutation of 5, 5, 5 permutation. It's read 5 permutation 3. And of course, when generally people read it, 5 permutation 3, they do it like this. Let me see if I can pull this document. No, I don't think it'll let me let me write it nicely. So 5 permutation 3. Again, that means 5 factorial on top and 5 minus 3 factorial in the bottom. This 2 is 5 minus 3. With me? I'll give you another example. Let me do another example, okay? Then we'll be ready for our little text box. Suppose You have five children. I'm just going to call them children because no, let's take six children. Children. Suppose you want to arrange six children on three chairs. Of course, we're assuming everybody uses one chair. Nobody's sharing a chair, okay? Generally don't share chairs. So, and here they're going to be photographed. Three of the six children will sit on three chairs and they'll be photographed. How many ways can you do it? So this time, the first chair can be filled in six different ways. The second chair can be filled in, there are five kids around, five different ways. The third chair in four different ways. Now, of course, you can multiply 6 by 5. That's going to be 30. 30 times 4 is going to be 120. I'm going to just quickly write the answer here as 120. You can also say, this is 5. Based on what we just learned, we can say permutation of 6 permutation 3 is 6 factorial. 6 factorial divided by 6 minus 3 is 3. And this is going to be 3 factorial. Okay? 6 factorial divided by 3 factorial. You can leave it like that, and trust me, it's going to turn out to be 30. I'm going to check it on your calculator. 6 factorial divided by 3 factorial, okay? $120. All right? So be aware of that, how this is written in two ways. It's hard for me to write in this manner. I will write it today. 6 permutation 3. That means 6 divided by 6 minus 3. So now, what if I give you something like this and ask you to express it in terms of factorial notation? That exclamation mark here is called the factorial, 6 factorial, factorial. Let's try it. What if I give you this? 7, comma, 3. And the context could be 7 kids, 3 chairs. You will say, well, that's easy. 7 factorial divided by 7 minus 3 factorial, which is 7 factorial divided by 4 factorial. Yeah, whatever that may be. Sometimes you'll write it like that, 7 factorial divided by 4 factorial. If they want you to find it integer using integer notation, you will have to write 7 factorial. Sorry, this is not really that bad. 7 times 6 times 5. That's all. Now, you might wonder, why do we care about the factorial notation? Because sometimes the numbers will be so big, you're better off leaving it in this format. Okay, guys? All right. Now we are ready for that slide that kind of officially allows us to start permutation. So what does it say? We have done two problems like this. The number of arrangements of R objects from N objects in which N objects are distinct. Our books were distinct, our people were distinct. Repetitions of objects is not allowed. You cannot, the same person can take two positions. Order is important, is given by this formula. Remember I told you they write NPR like this? And I've been writing it like this. Both are correct. You want to know that. Both are correct. This is written P and comma R. All right, guys? So that's a formal idea. Okay, permutations are, people find permutation problems a bit challenging. So it is really an aspect of counting principle, very specific aspect. What aspect? In the counting principle case, if you have n distinct objects or 50 distinct objects where repetition is not allowed, where order is important, you go for permutation. But you also have to understand the concept. If you don't understand the concept, you won't be able to do these problems. All right. So hopefully by the end of the day, you'll be able to do more problems from 5.3. All right, guys, let's see what else is here. I'll do a couple of problems. Okay, this is a good one. I'm just going to take the question. I have my solution here. It's from your book. It's an example from your book. So I'm going to check my answer just to make sure I got it right. Very easy to mess these things up. All right, so let's read it. In how many ways can horses in a 10-horse race finish first, second, and third? I have 10 horses. They're racing. And I have three specific positions, first, second, third. We're assuming there are no ties, okay? Those are assumptions. So I'm going to take a table, make a table, and make sure it has three slots. This is the first one, second, and third. Okay, how many ways? I'm going to do it from scratch. How many ways can you choose a winner for the first position? Well, there are 10 horses. It has to be 10 choices. How many ways can you choose a winner for the second position? One of the horses has won, so it's going to be 9, and then it's going to be 8. So I'm going to write your answer as a product of 8 times 9 times 10, which is going to be 720. Now, using our little fancy formula, I can also write N is 10, R is 3. There are 3 positions. And we know, now we are mature enough now, we can just say divided by not 3 factorial, but 10 minus 3 factorial, or 7 factorial. And I'm going to just go use my calculator to see if I really get 720. I hope I didn't mess up. All right, guys? 720. So we didn't mess up. Got it? The answer is 720. And let's check the answer in the book. 720. Good. We got it right. Let's try one more. Okay? Oh boy. What is for combination? I don't want to get into combination today. Okay, this is for the next class. So let me do a couple of problems from your book that involve permutation. Okay, just do a couple of problems. Let me find it. I'll go to your book. So it'll take me a little bit of time. Be a little patient. Okay. Um, so I don't want to start combination. You want to practice the permutation problems really well. Only then you'll be ready for permutation, combination. Let's do some of the problems from here. These are easy. Okay, this is a good one, guys. This is a good one. Let's try number 27. Okay, let's try 27 from your book. Excuse me. List all the permutations of 5 objects taken 2 at a time without repetition. 5 permutation 2, that's one way you can read it. I'm going to say, okay, that's easy. Permutation 5 comma 2 is, according to our formula, 5 factorial divided by not 2 factorial, but 3 factorial. What's 3? Well, 3 is 5 minus 2. And let's go here and let's find the answer using our little calculator. 20. Easy. Now, let's make sure we understand. So this, they're saying 20. It's not really that difficult to see what the lists are. Let's list all 20 of them, okay? You pretend A, B, C, D, E are 5 people. You have 2 chairs, okay? So how can we do it? The first order again matters. First, you can have A and B. We are starting with A and C, A and D, A and E, okay? If you include A in the first place, you're going to get 4 cases. All right. Now, of course, you can do BA, CA, DA, AE. Let's say you want to start with B, okay? You can have BA is kind of already over there. I'll tell you what I'm trying to do. You can choose BC, BD, and BE, right? So 5, 4, 5, 6, 7. Then you can start with C, CD, CE. And then you can start with D, B, E. That's it. But how many cases do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 cases, but the answer is 10. What's wrong? Well, I didn't actually make a mistake. AB and BA are different arrangements. Remember, order matters. AC and CA are different arrangements. DA and AD, AE can be written as EA as well. That's going to count as a different arrangement. So really, if you do it this way, you can really see there are 20 unique cases, 20 different ways you can arrange 2 of the 5 books in a row, or 20 different ways you can arrange 2 of the 5 kids in a row. Again, I have 10 here, but since order matters, you can flip them. The answer is really 20, and we got it right. Let's see what else we can do. 4 choose 2. You should be able to do 28. Now, I'm not going to do anything with C. Now, these are actually fairly easy, guys. Okay, I'm going to read a couple. I'm not going to do them. Number 32, a woman has 5 blouses and 3 skirts, assuming that they all match. How many different outfits can she wear? It'll be simply 5 times 3, 15, right? Suppose Dan is going to create a Spotify playlist of 12 songs. How many different ways 12 songs can be played without repetition? So to me, let's do this one. It's really no different from trying to arrange 12 books in a row. Okay. Clearly, they're saying there is no repetition allowed and order matters clearly. How do I know order matters? How many ways can a song be played without repetition? So order matters. It doesn't say arrange. They probably could have, but order matters. Now we have become mature enough. We know when you have okay, one important concept, guys. This bothers people a little bit. Before we get to that, I'm going to do it like this. What's 0 factorial? Okay. 0 factorial is not 0. 0 factorial is 1. All right. This is not that difficult to see. Ask yourself, if you have no books, how many different ways can you arrange no books? Answer is 1. So 0 factorial is not 0. All right. I'll do this problem number 33 in 2 different ways. All right. The first one, remember that 0 factorial is 1. So I have 12 songs. I have 12 slots. How many ways can I fill my first slot? 12. Then 11. Then 10, then 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. And that's simply 12 factorial, and you're done. You're done. And 12 factorial is a large number. I'll show you right now. It's too large. You'll be surprised to see how large it is. See, it's a large number, fairly large. So I'm just going to leave it as 12 factorial. Well, if you want, I'll put it here. All right. Now, using that formula, NPR, written E N comma R, using that formula, it says it should be N factorial divided by N minus R factorial. That's what it means. But here I have 12 songs and 12 slots. R is 12, N is 12. How do I deal with that? Piece of cake? But guess what? 0 factorial is 1. It's not 0. So either way you do it, you're going to get 12 factorial. Okay, guys? So we're kind of wrapping up. Let me find one more problem from your book. And feel free to ask me to do problems from your book. I will incorporate it in the next video. Let's try this one. This is a good one. 40, number 40. A social security number is used to identify each resident of the United States uniquely. The number, excuse me, of the form XXX, XX, XXXX. So it's really a 9-digit number, and from XXX 1, 2, 3, I think it's 9, I'm not off, and X is a digit 0 through 9. How many social security numbers can be formed? Okay, it's really a counting principle problem, and I'm going to make 9 slots. Okay, all right, so these are my slots. I'm going to just write the first one and the 9th one. You understand everything goes in the middle. All right, so clearly repetition is allowed. You can have 111 as a part of your social security number. We all understand that. So that tells me repetition is allowed. Does it say somewhere? No, it doesn't, but that's understood. Okay. So I'm going to say I have 10 choices, 10 choices, 10 choices, 10 choices. Choices. I multiply everything, and it's going to be a large number, right? So I'm just going to write it like this. It has to be 10 to the power 9. Done. That's my answer. Part A. And leave it like that, right? What is the probability of correctly guessing the social security number of the President of the United States? Well, there are this many social security numbers, okay? And he has one of them, whoever the president may be, right? And you just take one divided by that. That's your answer, which is very, very low. And you can write it like that. A very small number. So it's very hard to guess somebody's specific social security number. All right. So guys, that's all I have here for today. Um, what I want you to do is try some of the problems from 5.5. You won't be able to do anything that's directly related to combination. That's going to be our next discussion next class. Again, try some of the problems. I did a lot of examples from permutation 4 or 5, as you can tell. I will see you next class. That simply means I will record a video tomorrow. That's all it means. If you want me to do something specific from your exam or from homework problems, um, please email me, mention your course name, give me the number and a screenshot. I will try to incorporate your problem in the next video. Thank you very much. Bye-bye.